Berkeley, 1973. The university is staring at a lawsuit. Its own graduate admissions numbers look damning. 44% of male applicants were admitted, and only 35% of women. A 9-point gap, thousands of applicants. This is not noise. So the university asks a statistician named Peter Bickel to find out which departments are guilty. And department by department, Bickel finds something that should be impossible. The discrimination disappears. In most departments, women were admitted at an equal or higher rate than men. Every part of the university looked innocent. The whole looked guilty. Both sets of numbers were correct. This is Simpson's paradox, a trend that appears in every group of data can vanish, or completely reverse, when the groups are combined. It sounds like a mathematical curiosity, the kind of thing that lives in textbooks. It is not. It sits inside medical studies, salary reports, and political arguments, quietly letting two people shout opposite conclusions from the same spreadsheet. And by the end, you'll know the question that breaks the spell. So how did Berkeley look guilty and innocent at once? A hidden third variable. Which department people applied to? Women applied in large numbers to the most competitive departments, the ones that rejected almost everyone, of either sex. Men flooded into departments with high admission rates. Each department could be fair, and the totals could still tilt, because the pools were completely different sizes. Watch the machine do it. Group A trends up. Group B trends up. Combine them, and the total points down. Nothing was miscounted. The mixture did it. Once you know it exists, you find it in deadly serious places. A famous kidney stone study compared two treatments. Open surgery beat the newer technique for small stones and for large stones, but looked worse overall because surgeons had sent the hardest cases to surgery. In baseball, David Justice out-hit Derek Jeter in '95 and again in '96. Yet across both years combined, Jeter was ahead because the two men's at-bats were distributed completely differently across a good year and a bad one. Wage statistics do the same dance. It's arithmetically possible for every single occupation to raise its pay while the national average falls if the workforce shifts toward lower-paid sectors. The parts improve, the total declines, no one lied. And in a British study, smokers had a higher 20-year survival rate than non-smokers, until you split by age and found the non-smokers were simply much older when the study began. Every one of these datasets was accurate. Every headline written from the totals alone was wrong. Pause for a second and be honest with yourself. How many dashboards, headlines, and comparison charts have you trusted this week? Without once asking what groups were mixed together underneath the average. Now, the catch, and it's subtler than the pop version. The lesson is not always trust the subgroups. Sometimes the combined number is the honest one, and slicing creates the illusion. It depends on what the hidden variable actually does. If it's a confounder, like the departments, you split. If the split variable is a consequence of the treatment itself, splitting lies to you. The arithmetic cannot tell you which world you're in. Only the story behind the data can. How it was generated, who chose what caused what. That's uncomfortable, because it means no formula rescues you from thinking. Remember the missing planes from the survivorship episode? Same family of trap. The danger was never the math. It's the data you didn't ask about. So here's your defense, and it fits on a sticky note. When any statistic surprises you, a gap, a reversal, a scandal, ask three things. What groups were combined? Were the group sizes wildly different? And does anyone have a reason the mixture, not the behavior, could produce this? If the analyst can't answer, the number isn't evidence yet. It's an ingredient. And next time, a 2,000-year-old idea that predicts which books, tools, and habits will still matter in 50 years, using nothing but their age. Comedians discovered it in a New York deli. Mathematicians proved they were right. The Lindy effect. Next.